Hi, I'm Walter Lockhart, and welcome to my introduction to SOLO, Small Orbit, Large Orbit Peak Power Tracker Technique.
Let's look at a battery clamped PPT power system as shown here. This is done for simplicity. Show a solar cell array on the left side. This feeds a DC to DC converter. The converter output is directly connected to a battery, which we would call a battery clamped power system. So we have the battery string, have a load resistance. We have a current sense for the battery. The current sense feeds the Solo PPT controller, which in turn controls an error voltage back to the DC to DC converter to control the system. So this is what we're talking about, a battery clamped power tracking system. The DC to DC converter shown here could be a buck, a boost, a buck boost. It could be resonant, quasi-resonant. It could be isolated. The topology of the DC to DC converter is not important for the Solo controller. What I'm showing here is simply how the Solo controller would connect to a DC to DC converter, and that the system is designed for a battery clamped setup.
Alright, that was the introduction to SOLO. Remember that it's a perturb and observe system. We use large orbits to find the global power peak that you might have with a multi-peak solar array curve. We use small orbits to track the power peak in a fine manner. We use the error voltage to detect the power state. We use average battery current to sense the power peak. And this entire technique is easily implemented in hardware or in code.